This is a new topic. This is one of the final examples for the DeltaV tutorial. In this example and in this final project, we will use the calculation block in order to implement a complex PID application. We use a PID control algorithm for slide valves. Slide valves are somehow like the integrating actuators. They are not like the normal actuators. Normal actuators, you have the valve or the final element, and you have a command. In valves we have positioners. Positioners will determine the position of the valve based on the command. But in the slide valves, slide valves or like motorized operated valves, you have two binary commands, and by using those commands you operate the valve or operate the slide valve. This is a very simple example. In this example, we have the slide valve. This is the slide valve of a screw compressor. In this compressor, we use the oil in order to operate this slide valve. I will show you how to. It's possible to inject oil from the pressurized oil pump source, pressure oil source, in order to move the slide valve into the right side. I will explain it a bit more here. This is a zoomed view of this mechanism here. We have pressurized oil source, and we use two solenoids in order to inject the oil in this direction. When the oil is injected here, the movement will be the slide valve will be moved to the right side, and if the oil is injected in this direction, the slide valve will be moved to the left side. So by using two binary actuators that are solenoid valves, it's possible for us to determine the position of this slide valve. In the integrating actuators, if there is no command, the slide position will be intact and it will remain constant and at that position. So let me show all of you the slides. This is the slide valve, command from the solenoid and movement to the right side. You can see that the movement is in the right side, and we reach to the minimum capacity valve position, and if we inject the oil in the other side, the valve position will be moved to the left side, and you can see that. That's the maximum capacity valve position. So consider we have these binary actuators, and we want to use this binary actuator in a PID application. Normally we have seen that we have analog input, analog output. In this PID we have analog input, but the output to operate these actuators, the outputs are binary signals. So we have this algorithm, and we implemented that in calculation block within the DeltaV software package. And I will start function test the whole algorithm, and in the next video that is available only in the DeltaV tutorial in our website, you can see how to implement any given algorithm in that calculation block, and how to customize any algorithm in the DeltaV environment. So, and here I created a very simple graphic interface. First, I put the algorithm in the reset. I remove the reset. We reach to the close end, and I change the set value to 85. So the set value is 85. Action solenoid to open the slide value is operating, and the process value is increasing. Let me show you the graphic page here, the trend related to this algorithm. These yellow commands, these are the opening commands. Again, opening command, and the process value is increasing here. This is the set value, this is the process reaction, and these are the binary commands. And we have the simulated valve position. This is the simulated valve position. This is not actual value. We calculate that based on the traveling time of the MOV or the slide valve, and the duration of this pulse. This PID block, it has gain and the time integration time. We don't have D part in this algorithm, and you can see that duration is fading here, and we are getting close to the set value. Another short pulse here. The set value is 85 and the process value is 75, and we are getting close to the set value. This is the user interface, set value, process value, and these are the commands. Opening commands and closing command. These are the buttons in order to operate. We can put the PID in manual, we can manually open, manually close, and reset the whole program. we are reaching to the steady state, and we're getting so close to the set value. Let's check the user interface. The set value is 85 and the PV is around 85, and the error signal is very slim. I reduce the set value, and we can see that we receive the closing signal. Let me zoom. You can see these are the closing signal. We receive the closing signal. These are the closing signal. Again, we receive the closing signal. The simulated position of the slide value is declining here, and the actual process value is also declining here. The slide position is closing here. So it's a great tool. The calculation block in DeltaV is a great tool. You can use any given algorithm. You can implement your own algorithm to control any given process model. You can implement your own tuning algorithm or any other concept in your mind. You can implement that in DeltaV. This is another short pass, a short pass for closing. This set point is 17, and the actual process value is around 30. So we are reaching to the set value. So we are in the manual mode, and now we turn on the opening signal, and now I'm enabling the close signal and disable the close signal. Let us check the result here. You can see this is the process value increase in process value, and you can see that it will try, if you remove the manual mode, the algorithm will try to reach to the set value. So when you select the manual mode, you interrupt the normal behavior of the algorithm. You can operate open and close for function test. It's possible to function test the solenoids, and with the processing shut down, manual mode is very helpful. But in the process, when the process is live, I highly recommend to put the process in the automatic mode. So we are getting close to the set value. It's possible for us to again change the set value and see the result here. These are the mode change. You can change the mode to manual, open and close the valves, and then see the result. Again, we increase the set value, and again you can see that we have the opening signal on the open solenoid, and these are the pulses. The duration of the pulse, you can see that the duration is declining, and the temperature is again increasing, and we will reach to the set value again. This is the first part related to a slide valve control, PID for a slide valve control. And in the next video, that is only available in our website, I will explain how to import the code, how to modify, and how to function test. Thank you for watching.